Okay, so we're gonna go over the individual mastery. So it's increasing from 0 to 3 and 9 to 13. 0 to 3, 9 to 13. And this is because it is above the x-axis. And it is decreasing from 3 to 9. From 3 to 9, below the x-axis. It's concave up from 0 to 2 and 7 to 13. And it is, and this is because where g of x is increasing, and it's concave down 5 to 7. Yeah, 5 to 7 when g of x is decreasing. And so g of 0, so g of 0 is right here, and from 0 to 7, we add all this up, all the areas, and we get 6, but it's minus 1 because it is less than 7. 0 is less than 7, so we minus 1 because our g of 7 equals 1. So if it's less than 7, we minus 1, and that equals 5. So g of 2, we just calculate the area. Then we do 5 minus 1 is 4. And g of 3, calculate the area, minus 1, 3.5. Then we do g of 4, calculate area is 3. G of 7 is 1, because that's what it gives us. And then g of 9 is 0.7 plus 1. So now it's greater than 7, so we add 1. So instead of 0.75 for the area, which would be this area right here, we do plus 1, so it's 1.75. And the same goes for 13, plus 1, and 11, plus 1, 2.50, and 6.75. So then we go to our graph right here of f. Our g of x is in the normal, is in the, what's it called? Is in the pencil. And so the y equals g of x is in the pencil right here. And it follows the points from here that I graphed. And it's concave up, concave down, concave up. And then, so the h of x, which is minus 1, I just went from starting at 5 to starting at 4. So basically, I subtracted 1 from every single one of these values, and then that would be our h of x for g. So then after that, we got a, so we got d over dx, then we got 3 to x, ln, and should be that should be t minus 8, yeah, dt. So applying the second fundamental theorem of calculus, it's already going from 3 to x. So we just put negative ln x minus 8 and then dx, because we're integrating in respect to x, or taking the derivative with respect to x. So this would be derivatated or integrating in respect to x. So it's 3 to x negative x minus 8 dx. So when we have b, we have x to the fifth of the 1 cosine t to the third minus 1 over 2t dt. So instead of going from x to 5 to 1, we have to go from 1 to x to the fifth. So we just plug this in, cosine, then we do x to the fifth to the third minus 1 over 2 times x to the fifth dx, because we're integrating in respect to x instead of t. So we remove the t and we put the x to the fifth in, and dx, and that's the second fundamental theorem of calculus. So then we go to 3. So we have to evaluate the definite integral from 0 to 1 of ex over 10 minus ex dx. Dx. So our u would be 10 minus e dx, and our du is negative e dx. So, and our dx is negative e to the negative x du. So once we so this is the integral rule, the integral of 1 over u du, and And so because like this, negative e's, so it will be 1 over u itself, because this is, it could be said as 1 because this is u, so 1 over u, and then or equals ln u. So we have and because it's also negative, so we have negative ln parentheses absolute value bars 10 minus e to the x absolute values plus the little heart or the constant. And so but then we need to evaluate this in respect to the integral itself. So then we have ln of 9 minus ln of 10 minus e, and then that equals 0.21, and that is the definite integral of 0 to 1 of e to the x over 10 minus e to the x dx. And